We are going to start exponential and logarithmic functions. It is a lot, but
Did you get highlights? I'm not gonna tell. Beautiful. They look really good.
thanks. Okay. An exponential function is something where the exponent has a variable, okay? So it's a number, which is a constant. So this could be a 2, a 3, it could be 1/2, it could be any number, but the exponent is where the variable is. Now, these are all going to have, remember the word asymptote, okay? Which is a line that the graph of the function approaches. It's never going to cross. It's going to look like it touches it, but it doesn't actually cross. So here's our basic exponential growth. Why do we think we call it growth?
It gets bigger and bigger.
Okay, so as we go to the right, it's going to get exponentially larger. So this is an example.
Where you see that the bottom line doesn't touch actually.
It doesn't actually touch. This right here, this would be y equals 0 is our horizontal asymptote. So you can see right here. It's an exponential growth because b is greater than 1. So anytime it's a number greater than 1, so if it's like 2 to the x, 3 to the x, 10 to the x, then it's going to get bigger and bigger. Here are some important things. We have domain is all reals. What does that mean? It means I can plug in anything in for x. I can plug in negative numbers. I can plug in 0, positive numbers. The range, well, what's happening here? Y is greater than 0, right? It's not greater than or equal to, it's not touching, and it's above the x-axis. We already said the asymptote was y equals 0, and the intercept is 0, 1. Why is it 0, 1? What happens when I have anything to the 0 power?
It's 1.
It's 1. So when I plug in 0, I'm always going to get 1. Okay. All right, so let's graph y equals 2 to the x using a table of values. So in the beginning, we're going to do a table of values, and then we're going to start graphing them more quickly in the future. So let's start off with plugging in -1. What happens when I have a negative exponent?
You put a 1 over the
So it becomes the reciprocal, which would be
1 over 2.
1 over 2. 2 to the 0,
1.
1. 2 to the first,
2.
2.
4.
Okay. Okay, so again, in the beginning, whenever we're learning a new graph, we like to just do a table of values.
It's 0, 1. Not 2. It's always 1.
Because anything to the 0 power is always 1, right? That's one of our rules. So here, at -1, we'll have a half. And then 0, 1, 1, we have 2, 2, we have 4. Now, just graphing a few of these points, hopefully you can kind of see what's happening to the curve. We could plug in more numbers. What if I plugged in 3? What would 2 to the third power be?
8.
8,
Why is the one
right? If I plugged in 4, 2 to the fourth power, it would be 16, which would be off of our graph. But what do we want to make sure? It's curved, and we want to draw in the asymptote. So it's going to look like, okay, it's not always going to be 0. Remember when we talked about parent functions, and then what happens if you have a vertical shift? Like, what if I had 2 to the x plus 1? Everything would be shifted up 1. So all of this, the idea of the parent function and then comparing it to transformations will still apply. So here it's getting closer and closer. Okay. If you draw it that it's touching, that's okay. I mean, listen, if you were to graph this on your calculator, it's actually going to look like it overlaps with the axis because it's getting so close, because imagine if I put in -10. What is that? That's 1 over 2 to the 10th. What's 2 to the 10th? A really big number? Okay. Yeah, what is 2 to the 10th? Let's see. So, here, we can do that real fast.
I think I have it.
You have it?
Is it 1024?
Is it 1024?
Yeah.
Could be.
Yeah, it is.
Let's see if my calculator ever loads.
2 to the power of 10.
No.
1024. Wow.
Wow.
Yay.
So, if I were here at -10, how do you graph 1 over 1024?
It's just touching at that point.
It's going to look like it's touching at this point. So it's okay if you make it touch. Just don't go underneath the asymptote, okay? All right, so let's fill in the characteristics here. The asymptote was y equals 0. Make sure you put y equals. They don't have horizontal or vertical asymptotes. Okay, what was the y-intercept?
0, 1.
0, 1. Make sure you rate it as an ordered pair. Domains, easy. That's like a freebie point. And the range was
Y is greater than 0.
good. Greater than, not greater than or equal to, even though it looks like it touches, it doesn't technically. Okay, so that was exponential growth example. What's the difference with this one? It's getting smaller and smaller as we go to the right. So this is where b is between 0 and 1. So it's a fraction, like a half or 1/3 or 0.2. Domain is still all reals. Notice the range is the same. The asymptote is the same. The intercept is the same.
Just negative.
It's just basically if we took this and made a reflection in the y-axis, right? That's what those two graphs look like.
I get it.
Okay, so let's graph 1/2 to the x using a table of values. So 1/2 to the -1. What happens when you have something to a -1? It takes the reciprocal,
1 over 2.
just 2 over 1, which is just 2. 1/2 to the 0 power is 1. Obviously 1/2 to the first power is a half. What's 1/2 squared? Good, 1/4. So at -1, we'll go to 2, 0, 1, 1, 1/2, and then already at 2, it's getting really close to the axis. So it's going to go up to the left, down to the right. Okay. So here, right, we have our asymptote. Y equals 0, good. Y-intercept,
0, 1.
0, 1. Domain,
All those numbers.
and
Range.
Y is greater than 0.
y is greater than 0, so think bottom to top. It's still all above there. Okay, so those two graphs were actually,
Practice.
right, these, we had exponential growth and exponential decay, one example of each. But now what happens with our transformations? Okay. Okay, remember our H and K? The role of H and K, what does it do?
And makes it go up or down.
Yeah, it makes it, here, remember back when we did
On the back button.
parabolas? That should look familiar. So what did H do when we had a parabola? Moves it left or right.
Oh, yeah.
So that's a horizontal shift, right?
K was up or down.
Okay, that's a vertical shift. So that makes it go up or down.
Feels like it goes positive or negative.
Yeah, positive or negative. So we would have, this would be a vertical stretch. But more importantly, what I'm going to be concerned about is what happens when A is less than 0. So in other words, when there's a negative in front, what happens to the graph? It's going to be a reflection in the x-axis. So it's going to flip it. Okay, so those transformations should look familiar. We've done them with absolute value. We've done them with parabolas, right? And we will do them later with logarithms and then eventually with trig functions. Okay, so we're same thing. All the same information. This is what your worksheet's basically going to have. Okay, so we'll have like a table, domain range. We got to label the asymptote and the y-intercept. Okay, so what do we notice about this one? 2 to the x minus 2.
It's gonna shift.
So that's going to go down 2 units. But let's say we didn't know that for sure. What could we plug in? And I only gave you 3 spaces. We can always graph more if you want.
-1, 0.
So -1, 0, and 1 are the easy ones.
Yeah.
Okay, what happens when we plug in?
1/2 minus 2.
Okay, 1/2 minus 2.
Negative 1/2. Negative 1/2.
So -1.5. Okay. We plug in 0, so that's going to be, right, because 1 minus 2 gives us -1.
0.
And 0, good. Okay, so let's graph. So -1, -1.5 will be right there. 0, -1. And 1 and 0. Now, I could plug in more if it doesn't give you a real good view. So maybe, for example,
But that's on the 0 though.
that's okay, because what happens to the graph here? Normally, where would
Oh,
be our asymptote?
It would go like that.
So here, when we have here, whatever is k, that's going to be our horizontal asymptote. So just a little, so horizontal asymptote is always y equals k. So in this case, not 2, but -2. So here's what I want you to do at -2. Because we want to make sure we label, so we're going to draw and label the asymptote, because that's going to be important. So whatever we add or subtract, that's what the asymptote is going to be. Now we can draw
Is
it.
it fine if I say k equals -2 instead of y?
No, say y, because it has to be the equation of a line. K is just a variable that we use to represent that. What's the domain? All reals, and the range,
Y is greater than 2.
y is greater than -2. Okay, now we get more complicated right away. I have a horizontal shift and a vertical shift.
Man.
What do you want to plug in?
-2, -1, 0.
What do you want to plug in? Negative.
-2, -1, 0.
Okay. You can choose whatever numbers you want, right? Why would we, so why did Elijah say that? What does the x plus 1 do? It moves it to the left 1 unit. Remember how the h is like the opposite? So if it's x plus 1, it's going to shift everything to the left 1. Now, could you have still chosen -1, 0, and 1?
But how do we do
How do we know that it moved it to the left 1? Because the x plus 1. Remember on the previous page? what does H do? Right? It moves it left or right. If it was X, so if it was, what was it, 3 to the X plus 1? That moves it left.
-1.
But if it was X minus 1, that moves it to the right.
So that's right, right positive 1, right? And move it to the right 1? Or
This one, it moves it to the left.
Yeah, but one time, right?
Yeah, just one spot. But it doesn't matter. Guys, pick whatever numbers you want to plug in here. Okay? As long as you have the general shape of the graph and you have the asymptote right. What's the asymptote in this case? -4. So I already know here, I'm not going to cross that line. I can't cross that -4. And because this is positive, is it going to be above this dotted line or below? It's got to be above. So can I pick any numbers? Now, would I pick 10? No, that will be way too big to work with. So I work with numbers that are going to be easy to plug in here. So if I plug in -2, what's that give us? That'll be 1/3 minus 2, right? Which is -1 2/3. What happens when I plug in?
I'm confused now because it's -4 and this is -2.
Right there.
Oh, you're right. This should be a -4. Sorry.
Okay.
This should be a -4. That's a typo. So actually -3 2/3. That's better. What happens when I plug in -1? That will make that 3 to the 0. So that'll be 1 minus 4.
Oh.
And
Wait,
then,
why is it? Oh. Okay.
you got it? If we plug in 0, that will be 3 to the 1st. So that's just 3 minus 4. Okay, so -2. So that'll be really close to that dotted line. -1, -3, and 0. Again, you know it has to get closer and closer to that line, and on the other end, it's going to get bigger and bigger. So you already know the basic shape. Domain is all reals. How about the range? Y greater than? Good. Okay. This one has a couple of things going on. What do we have?
It has the vertical.
It's going up 3 units, the vertical shift.
And
It's going to be
vertical
flipped.
stretch and a vertical.
And this is going to be an exponential decay because it's less than 1.
yes.
Okay, so right away I know I'll put in my y equals 3 for my horizontal asymptote. Is it going to be above or below this line?
Below.
Below because negative. Okay, I'm not going to tell you what numbers to plug in, but just what numbers would be easy to plug in?
-1, 0, 1.
-1 is definitely easy because that's going to flip it, right? Now don't forget there's a negative in front. So just be careful when you simplify this because that negative stays out in front. So 1/4 to the -1 will make it 4, but then that'll be a -4 plus 3, -1. Okay, Gabe said 0 was also easy.
Wait, so that means it's underneath.
It is underneath. It's underneath because the negative. If what's in front is positive, it's going to go above the line. If it's negative, it's below the line. Okay, what happens when you plug in 0?
It just becomes 1, but then.
There's a -1. Good, 2. And then if I plug in 1, that'll be a -1/4 plus 3. So I think I heard 2 3/4. Okay, so -1, -1, whoops. 0, 2, and 1.
Yeah, really close.
Okay, range and domain is easy. Range is always going to be y is
Y has to
greater
be
than or
less
y
than.
is less than?
Y is all
Less
less
than-
than 3.
Less than 3. Too easy. Pretty easy?
Oh, we have one more. Okay.
Are we done?
No, we have one more.
Ooh, this one's a little more complex.
Last one.
Do we have the worksheet for that?
Yeah.
Wait, did you get?
Because this would be, so 1/4 to the 0 would be 1, but then there's a negative in front, so that'd be -1 plus 3. No, so anything to the 0 power. So, like, this would be, and then you have your plus 3 at the end.
Oh, okay.
That's right. Okay. You want to try this one?
Y equals 5.
The same reason when we do parabolas, if it was x plus 3 squared, it would move it to the left. Do you remember those? All right, guys, give this one a try.
Okay.
This one's going to have an asymptote at
5.
5. Good, so,
Oh, yeah, right one.
okay, just keep in mind order of operations say we have to do the exponent first before we multiply by -4.
So,
You want to plug in -1 or -2? Does it matter? -1?
I started with 0.
It doesn't matter. Again, you know where it's going to be.
Uh,
Is it going to be above or below this line?
below.
It's going to be
Below.
below because it's a negative. So when I'm plugging in numbers, if something doesn't work on the graph, just try a different number. You're not going to try really big numbers or really small numbers. You're going to, when I mean like you're not going to plug in -10. So here, -4, this will be 1/2 to the -2 plus 5, okay. That'll make that -4. But wait, doesn't that take the reciprocal?
yeah.
So 1/2 to the -2 would be 2 squared.
Which is 4.
1/2 to the -2, which, so that'll be
-11.
-11.
Oh. Oh. Yeah, so it's
Okay, so that one kind of went off the graph a little
why don't we
bit.
get closer to the line? So it's like, number like 4.
Well,
But we do kind of like a
let's plug in 0. Let's see what happens when we plug in 0. So that's going to be -4 times 2 plus 5, right? Because 1/2,
-3.
because that would be 1/2 to the -1, which would be 2. So that'll be -8 plus 5.
-3.
Good. Okay, anytime you have a negative exponent, you take the reciprocal. So 1/2 to the -2 is 2 squared, which is 4. So -4 times, this is 4, is -16 plus 5 is -11.
What?
When I plug in 0, this will be 1/2 to the -1, which is 2.
We should plug in 3.
How about plug in 1? 1 is the easiest one.
Yeah, 1 is 1.
Yeah, 1 is 1.
What? I got -1.
Yes, it
Well,
can.
No, it's 1.
No, because this will be 1/2 to the 0.
Oh, wait a
Not even
minute.
like me.
Oh, no.
So this will be 1. -4
Oh, yeah,
plus
this
5.
one.
Okay, so -1, -11 kind of goes off our graph.
Oh, yeah, that's 1.
I used to not understand. I used to not understand. I was a tree guy.